With this question, there will be more questions coming up. So we've got 4.1, 2, and 3. And then we've got a 4.4 over here. In the diagram, M is the center of the circle and PN is the diameter. KL is a tangent. First question, calculate the coordinates of P. Well, what you can do here is, you know that this is the diameter. You know that M is the center. So M is the midpoint from here to here. It's the midpoint. So you could use the midpoint formula. And so we know that the midpoint is already 3 and negative 5. Now we can just say that this is, let's say this is X and Y. Let's call that point number 2. Let's call that point number 1. And so you would say 7 plus X over 2 and Y plus minus 2 over 2. Okay, so the 3 must be the answer for this part. So we can then say 3 must be the answer for that part. And then the minus 5 must be the answer for that part. So the way that we solve this now is I'm going to take this 2 and multiply it over. So we're going to say 6 equals to 7 plus X. And then you can solve for X and you would end up with negative 1. And then for this one, you're going to take the 2 over, and so you end up with negative 10 equals to Y. Now this part here just becomes a minus 2. I'm then going to take the minus 2 over to the other side, and so that'll become minus 10 plus 2 equals to Y, and so Y would be negative 8. So then the coordinates of P would have to be negative 1 and negative 8. This question says, determine the equation of the circle in this form over here. Okay, so we have the center. So, and then we need the radius. So we know that the radius is this distance over here. So we can go work out the distance between these 2 points. If you wanted to, you could even work out the distance between those two. Or what some learners do is they even work out the distance between P and N, and then you just half your answer. Okay. So I'm going to go work out the distance between, let's go MN. And so my distance formula goes like that. And I'll use this as my point number 1 and this is my point number 2. And so that's going to give us 7 take away 3 plus minus 2 take away minus 5. Then just go type that on the calculator, and you should get a beautiful answer of 5. Okay, so now when we go fill in the formula, you're just going to go say x take away 3 plus y plus 5 equals to 25. Let me explain. So the x minus 3 is just because the center has an x coordinate of 3. The plus 5 is because this is a minus 5, and you know it's always opposite with circles. And then with the radius is 5, but you have to square it when you put it into the formula. Okay, a lot of people put 5 here. A lot of learners put 5 there, but it's the radius squared. Okay, and then this question says, find the equation of KL. So KL is this one for how many marks? Oh, 5 marks. Lovely. In the form of y equals to mx plus c. Very easy question, actually. What we should know is that when you have a radius or a diameter, and then you have a tangent, they always have a 90 degree. So we can say that the gradient of mn, which is this part here, multiply by the gradient of KL will give us negative 1. Why do I say that? Remember, when 2 lines are perpendicular, meaning that they hit at 90 degrees, then there is a special mathematical property that tells us if you multiply their gradients, it'll give you negative 1. So what we can go do quickly is work out the gradient of mn. So the gradient formula goes like this. And so I will use this as 0.2, that is 0.1. And so we could say negative 5 take away negative 2 over 3 take away, what is that x value? 7. And that'll give us negative 5 plus 2 is negative 3 over 3 minus 7 is negative 4, and that'll give us a positive 3 over 4 gradient. So now we know the gradient of mn, so we could say 3 over 4 multiplied by the gradient of KL should give us negative 1. So to then work out the gradient of KL, you could say negative 1 divided by 3 over 4, and it should give you negative 4 over 3. Remember, when two lines are perpendicular, their gradients, they are upside down. So if the 4 is at the bottom, now the 4 is at the top. And if this one's positive, then this one's negative. It's always like that. So we now have the gradient of the tangent, which is that one. So we can then say y equals to mx plus c, which then becomes y equals to negative 4 over 3x plus c. To find c, you need to sub in a point on that line that we're looking for, which is the tangent line. So we can plug in n's coordinates. So we could say negative 2 equals to negative 4 over 3 times 7 plus c. And so c would be 22 over 3. And so we could then say y equals to negative 4 over 3x plus 22 over 3. This next question, I see it got a little bit chopped off at the bottom here. So I'll just fill that in. It is a 3. Come on, why is my pen acting weird? That's a 3 over there. Whoops. Okay. So it says, for which values of k will this line be a secant to the circle? Well, let me explain what is a tangent, what is a secant, and then what is neither. So if you have a circle, okay, now a tangent touches exactly, whoopsie, it touches exactly like that. That is a tangent. If it doesn't go through, then it's called neither. Or it's nothing. Let's just rather say it's nothing. If it goes through, then it's called a secant. Okay, now, we know from the previous question that this line has a gradient of negative 4 over 3, and here they're using negative 4 over 3 for the gradient again. So it's parallel lines that they're talking about here. So we could have a line that does that. Whoops, let's make it parallel. There we go. You could have a line that does that. You could have a line that does that. As long as they're all parallel. You see how they're all parallel to each other? They all have the same gradient. Whoopsie. Okay, let's draw another tangent. And then let's do another. So they want to know, because remember, by changing this k value on a straight line, that is the y-intercept. So if you make k very big, a very big positive number, then you're going to get lines going up here where they're going to intersect this y-axis at a very large number. If you make this very negative, then you're going to get lines going all the way down here where they have a very negative y-intercept. Okay? So they want to know, what must the k value be so that the lines will be circles? So that the lines will be secants. So the secants are going to be all of those ones. It's the ones that actually cut the circle. So what we will do is we need to look at the two tangents. There's a tangent over there, and then there's the tangent that we already looked at. So if we can, because those two tangents will give us the boundary limit. They will be the boundary of where that all happens. Okay, so we already know this one's equation. It's y equals to negative 4 over 3x plus 22 over 3. So the k value there is 22 over 3. Now we need to go find the, let's go find this line's equation. It will be very easy, because it's going to be parallel to this equation. So it's going to have the same gradient. And then you can just plug in the coordinates of p, which we already found is negative 1, negative 8. So we can just go plug that in quickly. Oops, there's a negative there. Okay, and so negative 8 would be positive 4 over 3. Now if you take the 4 over 3 to the other side, you end up with a c value as negative 28 over 3. So that means that this line's equation would then be y equals to negative 4 over 3x minus 28 over 3. So that would be the k value for this one. Now, if you increase this k value, well, then your y-intercept starts going up, and then you get this line, and then you go up some more, you get that line. If you go up some more, you're eventually going to get there, and there. And then if you go up to 22.3, well, then your y-intercept would be about there. So we can choose, so if the k value is anywhere between this number and this number, then your line will be a secant, because it's within the boundaries of the tangents. Okay, it's a very good question, this. So we could say that the k can be any number bigger than, we're not going to say and equal to, because at that point it's a tangent. Okay, I'll show you interval notation now. And anything smaller than 22 over 3. If you would like to write it in interval notation, then you could say that k can be an element from negative 28 over 3 up to 22 over 3. Now, here's the last one for this question. So this is question 4.4 now. It says point A. Now, point A is not over here, but it says point A. Now, this part is critical that you understand. It says that it's got the same coordinates. There is a certain line that we've dealt with in grade 12 called the y equals x line. You know, the line that goes, woo, Kev, that was a bit skew, but it's the line that goes through the origin. And have you ever stopped to think about that line? It's called the y equals x line. It means that the y and the x values are the same at every moment. So for example, here, if the x value is 1, the y value is 1. Over here, if the x value is 2, the y value is 2. Over here, if the x value is minus 4, the y value is minus 4. So they are telling us that these two are the same. So point A is going to be somewhere along that y equals to x line that we've learnt about in grade 12 functions, inverses. So it says that point A, which we don't know, and B are not shown on the diagram. Okay? From point A, another tangent is drawn to touch the circle, which is the circle M, at B. Okay? So another tangent is drawn. So that could be, sure. So it says from point A, that could be in multiple places. You could, for example, have something like that, where point B is here and then A is on that line. Or you could have that, where B is there and A is on that line. As long as A is going to be somewhere on this line that I've showed you, and B will be the place where it touches the circle, and it must be a tangent. So it can't do this. You can't do that. That's not a tangent. A tangent has to just touch at one place. So, for example, like that, or like that. Okay? So we don't yet know where A and B is. We have no idea where A and B is, but I'm just showing you possibilities. From point A, a tangent is drawn to touch the circle at B. Show that the length of the tangent is given by that. Okay, so let's just, when this happens in mathematics, you just choose a scenario. So you're just going to call this point A, and you're going to give it the coordinates T and T. You're not going to say, yeah, but Kevin, isn't the X value negative over here and the Y value negative? Nope, you're just going to say T and T. If those coordinates end up having to be negative, mathematically, it'll work out, okay? Then I want you to go ahead and, or let's put it over here rather. Let's put it there, for example. Otherwise, you're going to think it's parallel to this tangent. Then, we're just going to go draw a tangent. Like that. So where it touches, that is the coordinates of B. Now, they want us to find the length of that tangent. Well, that's very easy. What you do is the following. Because it seems tricky. I know that it seems tricky, but all you do is you make a triangle, because there to the center and then to there, whoops. Then you know that this is 90 degrees because a tangent is always perpendicular to a radius line. So then what you do is they want you to find the length of AB. So you can just go use Pythagoras, because we already know this length. This length here is 5. It's the radius of the circle that we found in the earlier parts. Okay, we found that the radius was 5, remember? And then we could easily try, well, we could try to work out this length over here by using the distance formula. So that and that, we could use the distance formula. And then we could use Pythagoras to find that length. Don't know why it's 2 marks. It's a little bit more work than 2 marks, I would say. But anyways, let's go get the distance of MA. So MA, we use the distance formula. Okay, so I'll use point A as my number 2 and point M as my number 1. So we could say, now just use T. Just say T minus 3 plus T minus 5. And that'll give us T minus 3 squared plus T plus 5 squared. Great. Stop there. That's fine. There's nothing more you can do. Now, okay, so we've got this length and we've got this length. So Pythagoras, we are going to go and find this one. So we're going to have to minus. So we're going to say AB squared is equal to AM squared minus MB squared, right? Because this is point B. So I'm just using Pythagoras now. Remember, it's always the longest one, which is this line, minus the other one, if we're trying to find this. So check how easy this becomes, because now we can just do this. Now if you AM squared, so if you square this, then it gets rid of the square root, right? Because they just want the square. They don't want AM. They want AM squared. So if you had to square that, then it actually just gets rid of the square root. So there's AM, so we can just say T minus 3 squared plus T plus 5 squared. I know we're going to have to get AB by itself eventually, but I'm just saying the way Pythagoras works. We should say here Pythagoras. Okay, and then minus MB, which is 5 squared, which is just going to be 25. Okay, so now we're just going to go multiply all of this out quickly and simplify it. So that'll give us AB squared. Now, remember to put 2 brackets over here, but I'm just going to speed it up. So it'll be T squared minus 6T plus 9 plus T squared plus 9 on this part. This will give us 10T plus 25, and then this is minus 25. So these two would cancel. So we end up with AB squared is then going to be T squared plus T squared, which is 2T squared. And then minus 6T plus 10T would give us a positive 4T. And then a positive 9. And that's exact. And then to get AB alone, of course, we would take the square root. So AB would then be square root of 2T squared plus 4T plus 9. And there's what they wanted. That's also quite a good question. I don't know how they're doing it for 2 marks. I went and had a quick look on the memo because I was curious, and they actually did exactly what we did. So for 2 marks, that's a bit crazy. The next question for 4 marks, or the last question for 4 marks, it says determine the minimum. Well, if the length of AB is given by this expression, 2T squared plus 4T plus 9, then the minimum is when this stuff inside here is going to be as small as possible. So, because if you can make this number very small, the number inside here, if you can make that very small, well then the square root of that is also going to be small. So all you do is you just think about what type of graph is that. Well done. That's a if you said that that's a parabola. And because this number is positive, it's a happy parabola. Okay? So if we could try to find this point over here, this minimum value on that graph, then if you put that minimum value inside here, then this whole thing will be a minimum value, and so AB will be a minimum. So what I'm going to do is I'm just going to go take this expression, and I'm just going to try and make that expression. I'm going to try find the smallest or the lowest part of that expression, and that's the turning point. So I will use minus b over 2a, and so I will get minus 4 over 2 times 2, which is going to give me negative 1. That's not the answer. That just tells me the x value of this minimum value on this kind of graph. To find the actual value, I have to plug that minus 1 into this expression. and that'll give 2 minus 4 plus 9, which is going to be minus 2 plus 9, which is 7. So that is the lowest value that you could ever get in this expression. It's a 7. So then if you take the square root of 7, you get 2.65 units. That's a brilliant question.